Hello everybody and welcome. In this video I'll talk about how we usually classify numbers in mathematics. And one reason we do this at all is that some things you've learned in mathematics actually work only for a specific type of number. For example, you have learned how to factorize numbers. It would be more precise to say that you have learned how to factorize integers or natural numbers, because there are other numbers that cannot be factorized. So the main lesson here in general will be that we can be more precise about which numbers we are actually talking about when we talk about numbers. So let's start with the normal counting numbers, those that you can start counting on your fingers. Now, some people would start counting at 0, some people would count starting at 1, but after that most people would agree that we count by 1, 2, 3, 4, 5, and so on. And every number that we can reach in this way, starting at 0 or 1 and then counting up, is called a natural number. So also larger numbers like 110 or 111 are natural numbers. And on the number line, all of these numbers are points, starting at 0 or maybe 1, and then going to the right in steps of 1. If we also include numbers that we can find counting down, then we can also find negative whole numbers. And all the negative and positive whole numbers together are called the integers. So that is the natural numbers and negative whole numbers. But of course, there are more points on our number line. We can also find a number right between 0 and 1, for example. That is a fraction of two integers, 1/2. Or right in the middle between 2 and 3, we get 2.5 or 5/2. And every number that can be written as a fraction of two integers in this way is called a rational number. So this includes the integers, because integers like 4 can be written as a fraction. For example, a fraction with denominator 1, 4/1 is the same as 4. Now, there are obviously a lot of fractions. We can make the denominator as large as we like, so we can get ever smaller steps. So we can get fractions really close together here. So you may think that all numbers that we can find on the number line will be fractions in some way. That's actually not the case. For example, a lot of square roots are not fractions. We can find the square root on the number line, for example, using Pythagoras. So imagine a right triangle here with sides of 1 and 1. Then Pythagoras tells us that the hypotenuse squared will be 1 squared plus 1 squared, so that's 2 squared. So this side is going to be the square root of 2. And we can use a compass to find that point on the number line. So this point will be the square root of 2. And we have already sort of seen before that the square root of 2 is a weird number that cannot be simplified to any nice fraction. So we can find numbers on the number line that are not fractions. And we call those numbers irrational numbers. Numbers that cannot be written as a fraction of two integers. And we can find more square roots on the number line. So here we have a construction, for example, for finding the square root of 3. And usually, square roots of natural numbers will be irrational. But not always. Sometimes they are natural numbers again. The square root of 16, for example, is 4. So we have to be careful here. A square root sign is not enough to conclude that a number is irrational. Another famous example of an irrational number is pi, the relation of the circumference of a circle to its diameter. Here we see a circle with radius 1, so the diameter is 2, so the circumference of this circle will be 2 pi. Now we can't construct pi on the number line in the same way that we can construct the square root of 2 or 3, but we can imagine rolling this circle out on the number line. After half a turn, we have moved a distance of pi. So pi is also a point on the number line. And again, pi cannot be written as a fraction. So with these definitions, let's see if we can classify some numbers. So ask yourself the question first and then check if we both agree on the answer. Is -3 a natural number? No, it's not. If we count upwards from 0 or 1, we're not going to find -3. Is the square root of 16 a natural number? Yes, we've seen this actually. We have to realize first that it is equivalent to 4. It's the same point on the number line, and that point on the number line is indeed one of the natural numbers. 1, 2, 3, 4. Is negative 8 over 4 an integer? Oh yes, it's the same point on the number line as negative 2, and negative 2 is a negative whole number, so it counts as an integer. Is negative 4 over 8 an integer? No. Negative 4 over 8 simplifies to negative 1/2, and negative 1/2 is between two whole numbers, so it is not an integer. Is negative 4 over 8 rational? Yes, it can be written as a fraction of two integers, for example, negative 4 and 8. So it is a rational number. Is 12 a rational number? Yes. All integers are rational numbers because they can all be written as a fraction, for example, 12 over 1. So this is a good thing to keep in mind in general, that all natural numbers are integers and all integers are rational numbers. You can imagine the way we divide the numbers a bit like this. All the numbers you have encountered so far in mathematics are what are called real numbers, numbers we can find somewhere on the number line. And all real numbers are either rational numbers or irrational numbers. The irrational numbers that you know involve square roots or multiples of pi. And rational numbers may also involve square roots, but then the results of those square roots are nice fractions. For example, the square root of 4 over 9 is 2 over 3, because 2 over 3 times itself is 4 over 9. Now, some of these rational numbers are integers. So the integers are basically a special box inside of the rational numbers. And the positive integers, and often 0 as well, are called natural numbers. So 42 is natural, but it is also automatically, therefore, in the box of integers and in the box of rational numbers, and therefore also in the big box of real numbers. And as you see in this box, it doesn't matter how numbers are written. Some of them have been written as decimal numbers, some as fractions, some as square roots, and this is all fine, but there is more to be said about this, because there is an interesting relation between the question whether a number is rational or irrational and how it looks as a decimal number. And this will be the topic of the next video.